So hello everyone, welcome back. Today we will start a new course of C programming language. It is a very beginner friendly course and it is kept in mind that the viewers who are viewing this has no background knowledge of any programming languages. Today we will start only about the basics. We will study about the introduction to programming. We will study about different types of programming languages. We will study about compilers. And at the end, we will end our today's discussion with a discussion about variables, data type and constant. Today is going to be a very beginner friendly video. And today we are not going to do any coding in our compiler or in our IDE. We will just learn about few basics and few terminologies. So let's see in our first slide what we have. So in the first slide, it is said, what is programming? What is a computer program in fact? See here, I will read the statements first and then after that I will explain. So let's change our annotator. Yeah. See, what is a program? A program is a set of statements or instructions which tells the computer what to do in order to come up with a solution to a complex problem. Okay, suppose we have a complex problem. Suppose we have to find out Fibonacci series. It's a kind of series. Suppose we have to make a game. All this is a type of problem. Suppose we have to make a billing program. A program which will calculate the total bill of a customer in a shop. So these are all problems, right? These are all complex problems. So to solve this complex problem manually, it will take a lot of time. And we know computer is a very powerful machine and it can solve complex problems in few seconds. So to convey our purpose of program or convey our complex problem to the computer, we take the help of programs and the language in which we write instruction or say our instruction to do this, to do that to the computer, we take the help of a programming language. So what is programming language? Suppose I have a complex problem and I want the computer to solve it. Okay, so the computer will solve it, but to convey my message to the computer, I take the help of a programming language. Okay, now let's take another view of it. Suppose let's make a diagram over here. Okay, suppose this is my father. Just a minute. Yeah, suppose this is my suppose this is my father. Okay, now my father of the family is working the whole day in his office and he gets very tired in the end of the day. Okay, he's getting very tired at the end of the day. So he comes back to the home and to refresh himself, he needs or has thirst of any lemon juice or any tea, for example. But he is very tired as it is mentioned here. But I was at my home. But the problem with me is that I don't know how to make the tea. So my father comes and tell me that he needs some tea. He needs some tea. But the problem with me is that I personally don't know how to make the tea. But father knows how to make the tea. This is the father. And this is me. But father knows how to make the tea. So what will father do? Father will give me a set of instructions. Okay, so what are the instructions? Boil water. Boil water. Add sugar. Add tea. And at the end, serve. Right? So what will my father do? My father will give me a set of instructions and by following this set of instruction, I will get a tea prepared for him. I will get a tea prepared for him. Right? So if you consider the real world scenario, the father is the user of a computer. User has a problem or user has a demand or user has a need, that is the tea in this case. So what will the user do? User will convey the instructions to make the tea to the computer, which is us. This is the computer, this is us. This is the computer, this is us. So what will my user do? User will convey information to me or instruction to me and I will follow these instructions as a code or a program and will execute this or we will go as per this instruction and we will get our problem solved. That is, the tea is made at last. Right? So this is a very real life scenario where I am trying to explain you the programming language and the computer. And similarly, if you see this diagram which is drawn over here, if we remove all the annotations from here, if you see this program done over here, it is explained that suppose you want to add two numbers, say A and B. Suppose you have to add these two numbers, say A and B, or you want to find the product of these two numbers, C and D. Okay, suppose A has value 550012 like this, and B has value 991721, or big numbers. It is very difficult for us to calculate this in seconds, but it takes just few seconds for the computer to do this if you convey your information or convey this instruction to the computer correctly. Now see here, if you see this, here is a code in C language. This is a code, or you can say a program in C language, which is adding two numbers or finding the sum of two numbers A and B, where A has value 7000 and B has value 35000. Clear? So if you run this code in your computer, you will get the sum of these two numbers. Clear? Now you don't go to understand what is the meaning of int main, what is the meaning of this hash include stdio.h or return 0 or printf, but I am quite sure by the end of this lecture you will be quite familiar with these things. Clear? So have I made myself clear about what is a program? So what is a program? Program is a set of instruction or a set of code which the user gives to the computer to find a solution to a complex problem. Clear? Our problem was T, our problem was adding these two numbers, a product of two numbers, anything. We just write it in terms of programming language to the computer understands it and get the solution solved. Clear? Now let's move to types of programming languages. There are two types of programming languages. One is the low level language and the another one is the high level languages. Now low level languages is the older one. This is the older one. This came first. So low level languages are again classified into two parts. One is the machine language or the machine code, and the another one is the assembly language. This is also called machine code. One is called the machine language or machine code, and the another one is called the assembly language. So let's now see what is the machine language. See, it is the language or the code by means of which all the hardware components of the computer interact. So what are the hardware components? Hardware components of the computer generally mean that they are all the electrical components, right? Because computer is an electronic device. That means it can be the RAM. Okay, it can be the RAM. RAM looks like this. It can be the RAM. It is an electrical component. It can be the hard disk or the storage device. I am writing HDD. It can be the hard disk or the storage device. It can also be the CPU or the central processing unit or the processor of our instruction. So CPU interacts with the hard disk with the help of machine language. Hard disk interacts with the RAM with the help of machine language. The RAM can interact with the CPU with the help of machine language, and so on. So what do we draw the conclusion from here? That all the hardware components, all these things are the hardware components. These things are present inside the CPU. If you open a CPU anytime, you can see this. So all these hardware components interact with themselves or communicate between themselves with the help of a machine language or machine code. Now see, it is a common sense that they are electrical languages, and electricity has no language other than current is flowing or current is not going, or voltage differences, right? So they have no language such as the voice language or any kind of other gesture language like that. So they have only one means of communication, that is voltage, right? Current is flowing, yes, good, then this is a symbol. Current is not flowing, no, good, another not, this is another type of language symbol. So see, consists of only binary notation. Machine language consists of only binary notation, that is current is not going, see, that is 0 and 1. 0 means current is not going, 1 means current is flowing. If RAM gives current to HDD, that is a hard disk drive, that means 1 1 1 1, current is going. Now hard disks will change the pattern of the current flow, it is 1 0 1 0 1, which creates a voltage difference which is understood by the CPU itself, and the CPU will process this instruction accordingly, right? So this is the process of communication between the electrical components of the computer, and it is not possible for us to understand these things because it is very complex, right? So we can write here human beings cannot understand this. It is a very important thing. Human beings cannot understand the machine language or the machine code. So if you draw a graph of the communication line, 1 means current is flowing, 0 means no current is flowing. Again 1 means current is flowing, 0 means no current is flowing. So this voltage differences, that current flowing, not flowing, current flowing, not flowing, this voltage differences is interpreted by different components in different ways. So they work accordingly according to the differences. Okay, so this was about machine language. So we just got to understand about a brief about machine language, that it is a language of the computer or the internal parts of the computer, right? The hardware components of the computer interact with themselves. But to make the machine language a bit understandable, there is another type of low level language which is designed by the human beings, which is assembly language. So what is assembly language? It was discovered after machine code so that it could make the machine code a better understandable by the human beings. So see, we cannot understand machine code. So human beings came up with assembly code or assembly language so that machine code is a bit more understandable by us, right? Now see, we understand little bit about assembly code, but the computer can only understand one thing, which is machine code, right? So we will convey a thing in assembly code, and there has to be someone or a translator who will translate our code written in assembly language to machine language so that the computer can understand, because at the end the computer has to understand our instruction, right? We give the instruction in assembly code and the computer has to understand it. So to do this, there is a medium or a program called assembler. What is the function of assembler? Assembler is a device which converts the machine language to the assembly language. See here, it needs the use of a program, that is assembly language needs the use of a program called assembler so that machine can understand the assembly language. So what does the assembler do indirectly? So this is my assembly language. This is my assembly language. It goes to assembler and it gets interpreted to 1 0 0 1 like this, which is the machine code. So in fact, you can call assembler as a program or a translator which translates the assembly code to machine code. Why? Because computer can only understand the machine code, it cannot understand assembly code. Why assembly code is important? Because human beings made assembly code so that machine language is a bit more better understandable by us. Okay. Now we come to the next generation or the high level languages which we are going to study. See, we have many examples of high level languages. We have C, we have C++, we have Python, we have Java, we have Ruby, we have Golang, we have JavaScript. There are many. There are uncountable numbers of high level languages and many are also being discovered till date. So why are high level language so much popular? Because it is easier to read, because most of the high level languages come in English. Okay. Is it easier to write? We can write is high level language because it is understandable to us and it is easy to maintain. We can maintain a code, we can upgrade, we can bring updates to our code with the help of this high level language. It is portable and environment friendly. What does this last line means? Portable and environment friendly means that suppose this is my computer. Okay. Suppose I write a code in my computer. Okay. And this is any other computer in any other parts of the world. Okay. Now it is not true that the code I make in my computer and the code is successfully running in my computer. It is not true that it will not run in any other computer of the world. That means it is environment friendly, that is, it is barrier friendly. The code which I run on my computer will also run in your computer and also other computers of the world. That means it is portable, that means I can transfer the code from one computer to another, and environment friendly, that means it can have no environment barrier. Code running in my computer, it means that it will also run in your computer too, right? So these are the quite advantages of high level language. Let's repeat. Why high level languages are so much famous or popular? Because it is easy to write, it is easy to maintain, portable and environment friendly. Why easy to read? Because it's written in English. Why easy to write? Because we can understand English. Why easy to maintain? Because we can update our systems, we can bring changes to the code as we can understand it, right? Quite simple, right? So this was the feature of high level languages. So let's move on to the next thing. High level languages made the use of compilers. Yes, now we came to a new term, which is compilers. So what are compilers? Now if you skip back 2 minutes earlier, I have told you about a program called assembler. What did the assembler do? Assembler was a program which converted the code written in assembly language to machine language or machine code. Why? Computer can only understand machine language or machine code. So similarly, human beings can understand high level language very well, but it is also important for the computer to understand the high level language, right? Otherwise our code will have no purpose. So human beings came up with the compilers. So what does the compiler program do? A compiler is a device which converts the code written in high level language to the machine language so that the computer can understand it. So in other words, compiler is playing the role of assembler in case of high level language. So I can also write source code. So what is the source code? Source code is also called the code written in high level language. Okay, source code written in high level language. I'm writing here high level language. So source code, I am giving it to the compiler. Compiler is a program. Okay, so compiler is executing it and converting it to machine code, and it is giving to the computer. So how does the machine code looks like? 1010110 like this. This is the machine code. We don't know what is the meaning of this. The computer can understand this very well. Okay, this is machine code. Clear? So now let's move to the next thing about variables, data types and constant. So what are variables? So we already know what are variables. If we are done with algebra of mathematics, we know what are variables. Variables are like containers. They can store values. In programming languages, variables are also like containers. They store different types of data. Okay, what can be the type of data? The data can be an integer, it can be a real number, it can be a character, and also some other categories of data. But for the time being, we can keep in mind that variables are like containers, right? What does a container do? Container can store anything. Suppose biscuits, pencils, rubbers, eraser, anything. Similarly, variables are like containers. They can store different types of data, right? And they can store different number of data. Okay, clear? So let's see what is variables. So variable can have any name A, it can have a B, C, any name. Okay, let's move. See, I have just discussed about what is variables. I said variables are like containers, but to declare variable or to tell the compiler or to tell the computer another way that I have made a variable over here, we need to follow a few nomenclature. Okay, see, a variable can have alphabets, digits, underscores. It can have alphabets, digits, number scores. Variable name can start with alphabets and underscore only. But remember, it can't start with a digit. You cannot start any variable name with a digit, otherwise it will throw an error. An error will come, or the compiler will not understand our variable as a variable. Also, no white space is allowed. A variable name is always continuous. No white space is allowed. Okay, a variable name cannot be a reserved word or keyword like int, goto, etc. What is int? What is goto? I will tell you after some times. Just for the time being, remember that they are called keywords. Okay, so let's write what are the few valid variable names. Variable names which are valid. Okay, let's write over here. A variable name can have alphabet, digits and underscore. So it can be A, B, C, 1, underscore 1. This is valid. Okay. It can be capital A, underscore 2. This is also valid. It can be capital A. It can also be small a, small b, like this, like this, like this. Okay. But if I draw the invalid over here, if I write invalid nomenclature view, okay. See, this is invalid. 2a. This is invalid. This will throw error. Okay. It can also like this. If there is a space over here and this is b. This is not underscore. Okay. This is a space. This is a white space. Okay. And this will also throw an error. Because this has a certain meaning to the compiler, and the compiler will not understand this as variable. It will throw error. Okay. So here is some few variable names. Just try to keep the variable name as short as you can so that we can write our code very fast. It can be A, it can be B, it can be, so it can be A, it can be B, it can be anything. So try to keep the variable name as short as you can so that we can type our code very faster. So let's move on to the next discussion about data types. Now what are data types? Now if you have studied or listened properly about the variables, I have mentioned that variables can store different types of data. Now what kinds of data the variable can store here, we are going to understand it now. See here. It is a type of data which the variable is supposed to store or it can hold. So what are the types of data that a variable can hold? It can be int, we have already studied. It can be of integer data type. Okay, it can be of integer data type. It can be of real number data type. Okay, it can be also a character. Right? Now see, a very important point is made over here. A variable is supposed to be declared of respective data type of data of which it is supposed to be held before using. Now if you are having a purpose of using a variable in your computer or in your program, you have to tell the compiler beforehand the type of data which the variable is supposed to hold in the code. Okay, so how do we declare data type to a variable? So let's see now. See, if you want to declare a variable to hold integer type of data, we write int keyword. If you want a variable to hold float type of data or real number type of data, we use float or double. If we want to store a very long integer, a very large size integer of 15 to 16 digits, we use long int, and we use long double for long real number data and char keyword for using character. Now let's see how do we declare. Now you may have an obvious question that why real numbers 2 are here, float and double, real numbers by 2 are here. See here, float means less precision. That means very less spaces after decimal. Suppose 2 to 3 spaces after decimal. But if you want to find out a program or if you want to store numbers which have more precision, that is 15 to 16 numbers after decimal, we use double, which is more precision. Clear? So this is the advantage of float and double. And also see, the memory allocation of float is 8 and memory allocation of double is 8 and float is 4 bytes. Okay. Now what is this memory allocation? It is important for us to know where it is getting stored. Now once we declare a variable, the compiler or in our computer, certain amount of space get reserved in our RAM. Right? RAM has a certain storage limit such as 8 GB or there is also 4 GB like that. Right? So when you declare a variable, a certain space is reserved for that variable in our RAM. This is our RAM. Okay. So how much space is reserved for each variable type? Okay. See, 4 bytes. 4 bytes is getting allotted if the variable which we declared is of integer data type. So if we declare a variable of integer data type, we store or we allocate indirectly 4 bytes of space in our RAM, right? if we want to store a real number data type of very high precision, we use double data type, and for that 8 bytes is getting allocated in our RAM. Similarly, if we are storing character in our variable, 1 byte, which is very small, is getting allocated in our RAM. As simple as that. Now let's see how do we declare variable. Now suppose I have a variable A. And I want it to store integer type of data. So what will I do? I will just write this word int. I will write A. So by reading this or by checking this item or checking this sentence, the compiler can understand it that yes, A is a variable which is of what data type? It is of integer data type. That means it is supposed to hold only numbers. It can be negative numbers also, it can be positive number also. Now suppose I want a variable to hold real numbers. That means numbers with decimal. So what will I do? And the variable is same A. So what will happen? I will just write float A. Or if it is of more precision number, we use double A. As simple as that. So by reading this line, the compiler can understand that yes, A is a variable which is storing a real number of double data type and has 8 bytes of memory allocation in my RAM. And char is the keyword which is useful for storing characters. So if you want to declare a variable to store a particular character, so we use char like this, char A, and then after that semicolon. Okay. Now if you want to assign a view variable its value, suppose I declare a variable A to hold data of 5. Now 5 is an integer, so how do we declare it? So int A equal to 5. So what will line will do? The compiler will understand it this way. So yes, A is a variable, compiler will read that like this. Compiler will read int A is a variable of integer data type, that it will hold only integer values. And what is the value it is holding? Equal to is the assignment operator, that is assigning value to A. So what is the value of A? That is 5. Clear? Now if you want to declare a variable A to hold, or any other variable, say C variable to hold a real number data type. So how will you declare it? Real number data type of say 2.5121 like this. Okay. So how will you declare? So you will write double C equal to 2.51121 like this. As simple as that, and in the end you will write semicolon. That is the statement terminator. Clear about data types? I have made myself clear. So to use any variables in our program, we have to declare the data type of the variable or the type of data which the variable is storing before using the variables. So let's now see about keywords. See what are keywords? So keywords are some reserved set of words which have a specific meaning to the compiler. A variable name I have already mentioned while studying the variables, right? A variable name cannot be named with the name of a keyword. See, if I tell you at this point of time, you already know the name of few keywords. See, if I say few examples of keywords, see here examples. There is int. You already know what is int. Int is a data type declaration statement, right? You already have float. You already have double. You already have char. These all are keywords. They have a specific meaning to the compiler, and you cannot name variable, cannot be used to name a variable, right? Why it cannot be used to name a variable? You know it, right? Why it cannot be used? Because they have a different meaning to the compiler. A compiler will read this float. Yes, float is a data type declaration. Where is the variable? After it will search up for a variable name, right? Because if no variable name is found, then it will throw an error. It will say data type declaration is made, but whom to declare? The variable name to declare is not found. So as simple as that. So if you want to use a variable, right? If you want to use a variable, you have to declare it, but the name of the variable should not be of this type of data or any other keyword. Like this, there are also many other keywords. Let's see, have a look. See, in total, there are 32 keywords in C language. I am not reading it one by one. There is auto, there is double, there is int, there is break, if, for, if, like that. I am not reading it one by one. It would sound monotonous, but you can just have a look at this, and you will not use these things, this names for naming your variables. Clear as much? So this was about variables, data type and keywords. Now to end our today's class, to end our today's lecture, let's have a look at a sample C program. Let's see a sample C program. See, a sample C program starts with #include stdio.h. So what does this mean? See, so here let's first tell you the purpose of this code. This is the code for a C program which will print, if this is my output screen, it will print hello world. Okay. If this is my output screen, what will this code do? This code will print hello world on the screen. Clear up to this much? So now let's understand part by part what does the part of this code means. Okay, so let's see. See, the first line is #include stdio.h. So let's have a view of this. So what does #include stdio.h means? See, here hash is the preprocessor directive, right? What is the preprocessor directive do? It directs the compiler. Why compiler? Who is processing the code? The compiler is processing the code, obviously. So what will the preprocessor directive do? It will direct the compiler to include or to import stdio.h, which is a header file for printing in output or taking input. What we are doing here, we are printing hello world on the screen. So to print output or to accept input, we use this header file, which is stdio.h. After that, it is written int main. Int main is the point from where the C compiler or any compiler will start the execution of a code or start reading the code. So it is the entry point of a program. Int is a data type, we already know that, right? So let's see. So after the int main, we have hello world printf hello world. So this is a line or this is a function, you can say, which prints something, right? The part to print it is getting in quotes, right? This is the hello world. We are going to print this hello world on the screen, so we keep it in quotes and we use this line printf. Okay, and the end line is the return 0, which tells the computer or the compiler to terminate the execution of the code. The compiler will enter from the int main and will terminate or stop the execution of the code when it gets the return 0 statement. And after that, there is semicolon, which I have already mentioned. It is similar to the full stop that we use in our English language. That is to terminate statements, that is to end our few statements. So we end our statements with the help of printf hello world. See, here is a statement. We terminate it with the help of semicolon. Right? We don't use full stop over here. We use semicolons. And this brace opens and this brace close create blocks and separate them. So where is blocks being created over here? See, this is the main block. This is the main block. See, these things will be quite comfortable to you once you proceed with this course. I know, I'm quite sure that you are not able to understand it very clearly, but once you do the coding part few, and in the next video we will come up with the printing part. After that, you will be quite familiar with that. How what does this means, #include and all, int main and printf and all. So let's explain, or let's try to explain you once again. So let's change the annotated laser pointer. Okay. So what does this #include stdio.h means? So #include stdio.h is the preprocessor directive. Okay. Hash means the preprocessor directive. Suppose I have a code over here. Okay. Now who is reading this code? The compiler, obviously. So who is processing this code indirectly? The compiler is processing this code, right? So what does this hash do? The hash means is the preprocessor directive. Pre means before and processor means before processing. Director means to direct. Okay, if you want to want me to write here, I am writing over here. Pre means before. Okay, processor means to process. Direct. Directive means direct. So whom it is directing? It is directing the compiler that before processing the code, you include this header file, this stdio.h. Why? Because we are printing something in this program, and to use this printf function or to print something on the screen, we need this stdio.h header file, which allows us to do that function. Okay. Next we have the int main. int pen is the point from where the compiler starts reading the code. The compiler enters into the execution part of the code from the int pen. Okay, and there is printf, that is a function or the process to print few statements or the few texts. We use this printf line, and there is return 0, which tells the compiler that yes, our code is ended over here, you can stop the execution of the code and you may display the output now. We have nothing much to say now, so you may close the execution and you may display the output now. So return 0 terminates the execution of the code, and there is semicolon obviously, which is the statement terminator, which we use in case of full stop, in place of full stop, right? And there is braces, which creates block and separates them. Okay, so I hope I have made myself clear. So let's recap what we have studied. We have studied about programming languages today. We have studied about different types of programming language, the high level language, low level language. We have studied about assembly language, machine language. Machine language is only understood by the computer, right? And assembly language was made by human beings to make assembly languages, machine languages a bit more understandable by us. After that, a phenomenal change came with the appearance of high level languages, that is C, C++, Java. We are only going to study about C in this course, right? So high level languages is easy to read, write, maintain, and also portable and environment friendly. I've told you what is the meaning of environment friendly. That means a code which is running in my computer will also run in your computer and all other computers of the world, right? After that, we saw a few terminologies, that is data types, variables, keywords. What are variables? Variables are containers which stores some value. Value can be any type of data. It can be an integer, it can be a character, it can be a the real numbers, right? And also we have learned about data type declaration. How do we declare a variable to hold a particular type of data? That is, if we want a variable variable a to store integer type of data, we write int a then semicolon, right? So like this we have already learned and we have discussed. So after that we have came to what is keywords. Keywords have a reserved set of words which have a specific meaning to the compiler. There are 32 keywords in C. And after that we saw this sample code. Okay, and we have learned a bit or a rough idea or a bit sketch like thing about what happens in a C program or a code. How does a program or a code in C looks like? So this is how a code in C looks like. If you run this code is correctly written. If you see it over here, this hello world code is correctly written. If you run this code in your compiler, you will see that hello world is getting printed as an output. Okay, so that's all for today. In the next video, we will discuss how to print output in much detailed way. In the previous slide, we have seen hello world is getting displayed. But in the next video, we will see how to display text in different formats, that is in one line, separate line, like that. We'll also see how to print values of variable using a printf statement, and also some other escape sequence and also other few things. And also we will solve programs in C in the next video in the IDE. Okay, so thanks for watching today's video. In the next video, I will upload how to install the VS Code compiler in your system. And after that, we will study about printing output in C. So thanks for watching. So I will see you in a bit.